Hi, everyone. I'm going to talk about a different kind of logging, which is human-readable log messages, so don't confuse. Yeah. Hello, everyone. I'm Bingyu Shen. I am a research scientist at Meta, and I will present our work on improved logging to reduce permission overgranting mistakes. And this work is done during my graduate studies at UCSD. So nowadays, more and more services are moving to the cloud, and the users will access the services on the cloud, including many private information, such as emails, documents, social media, etc. So access control is highly critical to protect this kind of information, which allows normal users access while blocking malicious users' access. However, the prevalent access control misconfigurations have caused many newsworthy data breaches. And this instance and the breaches can be traced not back to aggressive attacks, but rather to simple technical or human errors. For example, Twitch leaked their whole website source code and created payouts during configuration change, and they made a mistake. And many other instances are also caused by human mistakes in the access control settings. And in the modern enterprises, the company usually have professional sysadmins to help solve access control-related issues. One of the most common issues they are facing are access denial issues from users. For example, when users try to access resources on web server, but the user access may be falsely denied by the servers. And we call such issues access denial issues, and the users will often see messages like access denied. And we usually turn to sysadmins for help. The sysadmins will make a diagnose and make configuration changes and to solve the user issue. The user issue may be solved, but if the configuration change grants too much access, it will be left unnoticed until months later, the hackers will find the vulnerability and gain access to the resources on the web server. So when sysadmins diagnose issues for server software, the logs provided the software are usually the main feedback for sysadmins. According to a previous study, among over 400 cases, 87% of sysadmins will examine the logs during their diagnosis, but the sysadmins are not developers. They will not check the source code or use debugging tools in their diagnosis. In other words, the sysadmins usually have what is provided by the software developers. And there are two kinds of bad logging practices in software. The first kind is that the logs simply do not contain specific or complete information. As shown in this example from Apache web server. Apache will perform different authorization checks at one location, including checking the request IP address, a method, or host names. When any of these checks fails, a logger will have one generic notification, such as authorization failure for this user, without pinpointing to the root cause, it's an IP check or method check or host name mismatch. And another kind of bad logging practice is that the developers simply do not provide any information when the access is denied. As shown in this example from Cherokee web server, it checks whether opening a directory is successful or not. And this error is silently ignored by the developers initially until later the developers find its location and add a log message for the checking the file permission. These are just two examples showing that why the current logging practice is bad. And one natural question is that how bad are these practices in real-world software? To understand the logging practices in software, we conduct a study on the popular server software and answering the following questions. First, how do the server software have no log messages when the access is denied? And second, when there are log messages, do the log messages contain specific or complete information related to the access? And finally, how do developers add or update the access denied log messages for sysadmins? We conduct a study by first finding the access denied locations and collect the relevant log messages. And our study covers 5 large server software, including web server, database, FTP, and file system servers. And based on the log messages we collected, we find that at each access denied location, even in the mature open source software, there are 14% to 70% of locations that do not have log messages when the access is denied. And we first look into each log message to understand whether the log information at each denied location is complete or not. And we classify this information with the traditional access control matrix model that includes the subject, the action, and object. And this is subject, action, and the object may be different in different contexts of software. For example, in the Apache web server, the subject is the web server user. And the action can be related to the get or post action. And the object are usually the files on the web server. While in Postgres, the subject is the database users, and the action is the query method, and the object is the table or database or column, etc. We find that even though there are log messages, the software will have the subject, object, action, or object information at different levels. And we find that log messages usually contain the object information, to help sysadmins understand what data is being denied access. However, we find that very few log messages contain the information related to a subject. The developers may assume that the sysadmins already know that who gets denied. But in many access denied issue cases, the sysadmins need to figure this out to make a correct solution. And we did an extra study to see where are these information located. And surprisingly, we find that this kind of information is usually available at the same function when the access denied location, which enables us to automatically find these locations, information in the software. And to answer the last question, we look at the historical commits that are related to the access denied location on the historical git commits. And we find that a lot of commits are made at the access denied location, which is used to add or revise the log messages. And note that because we as FTDD do not have a public git repository, so we omitted the detail for that. And it shows that the current access denied logging practice is pretty ad hoc. And many log messages are added by the developers as afterthoughts. So a natural question is that can we automatically improve the access denied logging? To help developers enhance the existing log message and insert the missing log messages, we propose a tool called SECLOG to provide guidance for sysadmins to fix the access denied issues without overgranting permissions. And to automatically improve the logging, we need to make 3 design choices. First, how to log. We need a tool to improve logging. And second, where to find the logging opportunities and where to add the logging. And finally, what should be added in these log messages. For how to log, the current approach is highly rely on the developers to manually log. And this comes with 2 disadvantages. First, there are many logging locations in a big software, and the developers need to manually examine the code chains to collect relevant information. While for SECLOG, we think that the static analysis tool can be used to automate the process. This can also be integrated into the development process, such as a linked rule in the Fabricator or a plugin for IDEs. And for the next question, where should we add the log messages? The first aspect is that where should we find these access control check locations? And during our study, we find that the access control check functions are widely used to encapsulate the checking in different software. And for example, in this function, in Cherokee Web Server, it is used at 5 locations throughout the software, while this function in Postgres is used at 34 locations. So SECLOG will use access control check functions to find the access control check locations, which requires some developer input for annotation, but it is still better than manually going through all the places. And second, where should we place the log statements? There are two options. One is we can just place the log message inside the access control check function. And the other option is to place at the access control check function's call site. This comes with different pros and cons. For logging inside the access control check function, it comes with the lower analysis cost, but it results in the same generic logging for different checks, and it may miss the information at the call site. While logging at the call site will have more comprehensive info, but with a bit more analysis cost. And SECLOG will use the approach to logging at the access check function's call site. And finally, what should be added in the access control logging? And the critical information, as you described earlier, it's in two places. One is within the access control check function, and the other one is at the function call site. So SECLOG will use static analysis to extract relevant variables. I'll just give a simple example. For example, within the access control check function, we can start from the return value and perform backward slicing to find relevant parameters. For example, from this return variable, we can slice backwards to find the relevant parameters. And in this case, it is related to the directory and the opening mode. While for the second return value, it is related to the directory and the open permissions. And for the final return value, because it does not represent access deny, so it will omit this case. And at the function's call site, we will perform similar analysis, but mainly based on the data dependencies. Finally, for our evaluation, we conducted a comprehensive evaluation on the log improvements to see the overall results and the helpfulness. And we also did a user study, etc. For the other studies, please have a look at our paper. For the evaluation, the SECLOG can insert 380 new log messages and enhance 550 existing ones. For the existing log messages, you can find from 1.6 to 8 new variables at the access denied location, while for the new log messages, you can find 6 to over 100 places. And currently, we have submitted over 100 log message improvements, and 70 of them have been accepted by the developers. We also did a user study to see whether it can assist the sysadmins in fixing access deny issues. And we recruited 32 work professionals, and the users are divided into two groups. One with the log message, one with the enhanced log message, and one with the original message. And the only difference is the log message. We find that there are like 27 insecure fixes in the group with original message, while only one user in the enhanced log message group did an insecure fix. And we also find that the SECLOG can reduce the time in diagnosis by 3 times. And in conclusion, in this work, we did an observation study on existing logging practices, which calls for better logging for the access control administration. And we make the design choices for the improved access deny logging, including how to log, what to log, and where to log. And this can be also helpful when you are making your own software. And that concludes my talk. I'm very happy to answer any questions.